Okay, thank you. Do you remember this circuit? Okay, what was the question? We wanted to analyze this circuit and find the time domain expression for V of t. What is V of t? The voltage across these 2 points or at the terminals. What is going on? Okay. So, what was the first step we did last time? We used node voltage in time domain. So, is there anybody who doesn't know how we reached to this equation? No? Okay. After this one, if we want to find V of t, we need to get inverse Laplace transform. So we have V of s. How do we get V of t? We need inverse Laplace transform. So please, if you want to learn, you have to listen to me, because whatever I teach today, you will be using in future. If you have any questions, if any part is not clear with you, just gently raise your hand. I will answer your questions, and I'm going to explain every and each step very clearly. Okay. Inverse transform. This kind of equation, whenever you see, we call it rational function. So because we are in S domains, we say rational function of S. So we have numerator and denominator over here. We need to find the inverse transform of a function, this function, for example this, or this circuit. It has the form something like this. So a(n) times s to n plus a(n minus 1) times s to n minus n plus a naught. And over here we have bm times s, order is m. What is the maximum order for this part? N. And what is the maximum order for denominator? M. Okay. The ratio n of s over d of s is called a proper rational function if m is greater than n, and we call it improper rational function if m is smaller than n or m is equal to n. Questions? So whenever I say I have a proper rational function, it means m is greater than n. What is m is greater than n? The maximum order you see in the denominator. So if m is greater than n, we call it proper rational function. If it is smaller or equal to n, we call it improper rational function. Any questions? So you know the difference between proper rational function and improper rational function. Okay, it was easy. For first, we consider proper rational function. It means m greater than n. For example, if we had a function like this in S domain, first we find the roots. So what are the roots for this function? 0 minus 3 and minus 1. We have 3 roots or more or less. How many roots do you see over here? 4. What's your name?
Alex.
What's that?
Alex.
Alex, okay. Alex says 4 roots. Any other answers? How many roots? What is the maximum order for the denominator over here? 3? Louder, I don't hear. 2? Eric says 2. Any other answers? Omar says 4. I'm sorry, I forgot your name. What's that? Anish. Okay. Anish says 3. It's not auction. Okay. 3, 2, 4. Which one?
4. It's 4.
4. Why? Because the maximum order for this one is s squared, and you have s over here multiplied by s, it will be s to 3, and another s over here, s to 4. So it means you have 4 roots. 4 roots. Because the maximum order is 4. So what is the first one? S 0. What is for this one? S plus 3 equal to 0, which is minus 3. And how about this one? S plus 1 is square. It means you have 2 roots at minus 1. So now you have 4 roots. Minus 1 is repeated. Questions? Eric? Clear? It's a game. Okay. This is our rational function. So we have something like this. We have one, we just write it like this. Is that clear? Okay. K1 over S plus K2 over S plus 3 plus K3 over S plus 1 square and plus K4 over S plus 1. So we need 4 coefficients. We call them K, K1, 2, 3, 4. So what is the inverse Laplace transform for this one? K1 over S, and K1 is already a coefficient, a constant. So what is 1 over S if you get the Laplace transform? Ut. Yes. So that's why I wrote over here K1 times U of t. And how about this part? K2 over S plus 3.
It's a transformation. Shifted.
Yeah, what is the inverse Laplace transform of 1 over S plus 3?
E to the negative 3t.
Yes. So that's why we have K2, e to minus 3 times t multiplied by ut, plus how about this one? 1 over S plus 1 whole square. I forgot to bring the tables, but you have it. I posted on Bright's test. Yusuf, did you find the tables? Okay. One over S plus 1 whole square is t times e to minus t. So we have K3 over here, that one. We have it over here, multiplied by this term, ut. And how about this part? Again, K4 times e to minus t times u of t. So what is the problem now? The problem is that we don't know the values for k's. So we are going to find values for k's. How many k's we have over here? 4 k's. So how to determine these coefficients? So we find the roots. So the roots we just have 4 kinds of roots. The first kind is real and distinct. It means there is no repeated roots in the denominator. The second one is complex and distinct. Third one, real and repeated. And the fourth one is complex and repeated. So how about this question, this example? Which one of these is this? Is real, because we just have real. Is it real and distinct or real and repeated?
Repeated.
Real and repeated.
2 same roots.
What's that?
2 of the same root.
Yes. We have 2 roots at -1. So first, I am just talking about proper rational functions. It means m is greater than n. So for the first proper rational function, we have distinct real roots of d of s. Okay, for example, we have this function. How do you write it? K1 over s plus K2 over s plus 8 plus K3 over s plus 6. Any questions? Any problems how to write it like this? No. Yes.
In the above equation, why did we multiply everything by u of t?
Okay, last time I explained we are using one-sided Laplace transform. That's why we have from 0 to infinity. Yes, Brad.
Why is it distinct if we have a one root repeated?
So for this one, we have real and repeated for the previous example.
Oh.
This is another example. This is another example for distinct real roots. Do you see any repeated one? No, we don't have any repeated roots over here. No, no. That was just an example. Okay, for this one, we have distinct real roots. So if we have functions like this, how do we solve it? First, we are going to find K1. So this is our function. If you want to find K1, see the denominator of K1. What is the denominator of K1? Is S. Okay? So multiply both sides of the equation by S and then evaluate at S0. How? So, okay, if I multiply this part by S, I will get this. This S and this S will cancel out each other. And this one, I have K1. And for this one, I will get something like this. And for the third part, I get this. Now I'm going to evaluate both sides of the equation at S is equal to 0. So if I put S0, this is 0, S0, this is 0. I just have K1 in the right hand of the equation. And for this one, if you put 0, you have 96 times 5 times 12 over 8 times 6. So K1 is 120. Questions? Omar, do you have a question? Here?
Just repeating that part, almost every step in the first study. So you said that the thing you send your S2 is the value that is 0?
So for K1,
I'm just wondering for the S in all
both sides of the equation, just multiply by S. So for the left side, you will get that one.
it was more, I'm wondering about the setting of S. You just said to K10.
Yes, because the root of k1 is 0 for the denominator, that's why I evaluate it at 0. Thank you for the question. So why did I evaluate both sides of the equation at s equal to 0? Because this is the root for k1 is 0. So for k2, the same procedure for k2. What is the denominator for k2? S plus 8. So you multiply both sides of the equation by s plus 8. You will get this, k1 this, plus k2 plus k3 times this term. So now I evaluate both sides of the equation at what? S equal to s minus 8. Why? Because the root for this second term is minus 8. So it just substitute minus 8 wherever you see s. So you will get minus 72 for K2. Questions? So how about K3? Multiply both sides of the equation by what? S plus 6 and evaluate it at?
-6.
-6. Yes. So K3 will be 48. So you have this equation, K1 is 120 over S plus K2 is 48 over S plus 6 minus 72, which is K2 is minus 72 over S plus 8, and this is K3. So get the inverse Laplace transform. (120 over S is 120 times ut plus 48 times e to minus 6t times ut minus 72 times 8 to minus 80 times ut. So that is the final answer. Yes.
Will we be given the Laplace transform tables on the quiz?
Yes.
On the quiz.
Quiz also, yes.
How come in the last example we didn't solve for K1, K2, K3, K4? Did we just
I just wanted to introduce the function, proper rational function. That was just an introduction. Okay, questions? So whenever you see this thing real, proper rational functions, this is the way and this is the procedure how to find k's or the coefficients. Practice assessment problems 12.3 and 12.4. So any questions? The second part for proper rational functions was this thing, complex roots of d of s. For example, you had this function how would you solve f of s? So again, f of s is equal to k1 over s plus 6 plus k2 over s plus 3 minus j4 plus k3 over s plus 3 plus j4. So you have this thing, complex roots. Okay, for K1, you multiply by S plus 6, both sides of the equation and evaluate at s minus 6. So if you multiply this part by s plus 6, you will get this, because this one and s plus 6 will cancel out each other. You will get this and k1 plus k2 times this term plus k3 times this term. If you evaluate both sides of the equation at s is equal to minus 6, this is 0, this is 0, you have k1 which is minus 12. Minus 6 plus 3 is minus 3 times 100 over, if you put minus 6 over here and minus 6 here, you will get 25. So k1 is minus 12. For k2, again multiply both sides of the equation by s plus 3 minus j4 and evaluate it at minus 3 plus j4. Both sides of the equation. The same procedure. So if you solve it for K2, you will get this one, which is the final answer, and I hope nobody has problem with converting the rectangular form to polar form. And how about K3? Again, the same procedure, multiply by s plus 3 plus j4 and evaluate it at minus 3 minus j4. You will get this one, the final value for K3. So use inverse transform to convert it or transform it from the s domain to the time domain. So for the first one, minus 12 times e to minus 60. And how about this part? Okay, this is a constant, so we just put the same value over here. And how about this? We have e minus j3 minus j4 times t. This is like that, s plus 6, we have minus 6 over here. So again, minus j3 minus j4. Sorry, there's no j. There's no j over here.